It takes massive compute, and luckily it's amenable to parallel compute. And so how do we do all these amazing applications like computer vision, speech recognition, natural language processing we'll talk about in a second? Do we code these algorithms? Do we say, if I see this, then do that? No. It's no if then else rule-based programming. We take a network and we feed it a bunch of data, and we do this optimization thing where we optimize the weights, and at the end, if it converges to an accuracy we're happy with, we say we're done, and we can use it. And so there have been a set of developments since that magic year of 2012 where deep learning frameworks were constructed by a lot of companies, and luckily for all of us, they're all open source. So it's really an open source kind of an ethos or philosophy, and TensorFlow, MXNet, Caffe, Torch, Tiano, I'm sure you've heard of some of them. And so what they do is they very efficiently let you construct these networks and train them. And you can train them on different types of compute power, but what you'll find is that if you have very much data at all, you want to use parallel computing. Otherwise, it'll take an unreasonable amount of time, and that's where GPUs come in. I'll talk about that at the end. I am badly in need of speeding up. So very quickly, you realize that it goes beyond just a one-trick pony. It's not just speech. It's not just computer vision. Using these frameworks, you can plug a vision network into a language network, and you can say, be great, not just to say that that lower right image on the left is a cat, but it's a black cat sitting on top of a suitcase. Well, guess what? They took a trained image network that could say that's a cat, that's a suitcase. They put human annotated or labeled images, and they trained it, and the computer generated those annotations. And I don't think you can tell the difference from a human. Now here's the other beauty of it, is that these frameworks allow cross-pollination of different verticals. So someone in medical research, and a lot of these things are research. So this paper on the left was from Stanford. A lot of them will post their code on GitHub, open source. You can take that code in these deep learning frameworks. A medical researcher took that and said, if you can do that, I'll bet I can replicate or imitate the diagnosis the pathologist or radiologist would have given of these chest x-ray screening for lung cancer, and it worked. And so these frameworks allow you to take an example that's very close to what you want to do, but often in another domain, and very quickly get something that's working, at least for research. Getting it to production, of course, is a whole other challenge. I'm going to speed up, but it's